Hello, my name is Bailey, and I'm going to be talking about nanotechnology and friction. So, first of all, nanotechnology is defined as the branch of technology that deals with dimensions and tolerances of less than 100 nanometers, especially the manipulation of individual atoms and molecules. So, we're dealing with such small things that we can't see with the naked eye, and we're manipulating them in such a way uh, in our technology to our advantage. And some examples of this is in clothing and mechanics. And with clothing, there's a material called Kevlar, which is a material that's woven so close together and tightly knit that a bullet can't pass through, and a person on, for example, a highway who falls off a motorcycle or a vehicle onto the pavement, it will not tear and will protect their skin a lot more. And for obvious reasons, those are both things that motorcycle riders use, and also people in the armed forces. And friction is defined as the resistance that one surface or object encounters when moving over another. And I'm going to use an example to describe exactly how friction works. And the two main factors that contribute to how much friction there is weight and also surface area. So with this pencil, if I don't put very much weight on this smooth countertop, there's minimal friction and it moves smoothly across the countertop. But if I put a lot of weight on, there's a lot of resistance, and causes a lot of friction and heat. And with surface area, if I use this piece of tape that has a sticky surface and then also this pencil that has a smooth surface, if I slide it across the smooth countertop, there's minimal friction and also minimal resistance and heat. But if I use this piece of tape that has the sticky surface on the smooth countertop, it takes a lot more force to move it along, which causes more resistance and also more heat. And using nanotechnology, we can either increase or decrease friction. And there's different aspects of technology that we want a lot of friction, and then there's other aspects that we don't want a lot of friction. An example of this where we want both is in the car. Where we want a lot of friction in the car is in the tires, because that's what grips the road and accelerates the vehicle, and it's also what stops the vehicle. And if you manipulate the atoms and molecules to such a degree where almost all of them are gripping the road, then we can accelerate the vehicle much faster, and we can have more control around turns and stops, because every single atom is gripping and causing that friction on the road to stop it or to turn the vehicle. Where we don't want friction is in the engine. That's what creates the energy for the wheels to turn, and the pistons move along inside the engine up and down, and they move by the force of explosions. And since they're moving at such high speeds, it causes a lot of friction against the walls inside the engine and also the piston, which is bad for the engine. And so we try to minimize that friction with oil, which lubricates those metals, and so that's not causing as much friction. But if you use nanotechnology to reduce every single molecule and atom that is causing the friction to a minimum, then your engine will run much more efficiently and it will last much longer. And so those are some examples and some definitions of how nanotechnology and friction correlate with each other.